All right, today we're going to look at section 6.6, which is solving radical equations. We're picking up right where 6.4 left off. We are skipping 6.5 for now, which is graphing, because I believe that the inverses will complement what we're doing right now with 6.6, and hopefully you'll see how it's just kind of continuing what we did yesterday. What we're going to do today is solve. We're going to use the ideas of inverses to help us solve these equations. The one maybe new thing that you might see here is checking for an extraneous solution. Towards the end of the lecture, we'll probably get through one that we'll pull from other chapters, and you'll see hopefully how it fits together with what we're doing here. The other thing is today's probably going to be maybe 25 minutes, so we'll kind of keep it at that time length, hopefully. All right. First problem that we're going to look at is how to do it. These directions are also written on section 6.6 in your textbook on page 452. What we're doing is solving. What we're going to do, name of the game, get the radical by itself. So use our rules of algebra to move things across the equation. We're going from simplifying, which we've done in the past, to solving, which is what we're doing today. We're going to introduce exponents on both sides of the equation, and then we're going to solve. Ideally, this is going to look pretty easy. Ideally, it's been intuitive. Ideally, if I challenge you to do it without any help, you probably would have thought about doing this anyway. The last step, like I said, that's the new one. We should, when we have more than one answer, you need to check for extraneous solutions. The word extraneous, once again, means extra solutions in this case. So we'll check for extraneous solutions because sometimes both of them will work, sometimes one will work and the other one won't, and sometimes neither one of them will work. So we got to check for extraneous solutions, and that will kind of come at the tail end of the lecture today. So the idea, isolate the radical, get it by itself, use an exponent to eliminate the radical, solve the equation, check for solutions. Pretty straightforward. What's it going to look like? Well, I'm glad you asked. Here we go. First example is going to be 2 times the cube root of x minus 3, and that's going to be equal to 4. I'll give you guys a second to copy that down, and then we'll get into solving. Some of you guys probably can solve it right now. Name of the game, get the radical by itself first, introduce an exponent to get rid of the radical, solve the equation, check your work. So first thing we're going to do, get the radical by itself. In this case, it's 2 times the cube root of x minus 3 equal to 4. First thing I want to do is get rid of that 2. I will divide both sides of this equation by 2, and that gives me 2 cube root of x minus 3. Oops, not 2. The reason I divided by 2 was to get rid of, I hate it when it does that. There we go. That's what I wanted to do. Gives me the cube root of x minus 3 equal to 4 divided by 2. What you guys just told me is 2. I've got the cube root of x minus 3 equal to 2. I've isolated the radical. At this point, I will introduce something on both sides of the equation that will eliminate the radical for me. Remember, I can do whatever I want to an equation as long as I do the same thing to both sides. In this problem, I want to introduce, this is a cube root, so I will introduce an exponent of 3. I will introduce an exponent of 3 to both sides of the equation. The cube root of x minus 3 cubed, this will simplify to just x minus 3. Really, Mr. Wood, that's all it is? Let me show you it another way. I can write x minus 3 to the 1/3 exponent. That is the exact same thing as the cube root of x minus 3. I've been telling you that for the last 2 or 3 days so that you see the similarity here, because when I introduce the exponent of 3, all I do is distribute it, and 1/3 times 3 is just 1, and that's how I get x minus 3. Same. Make sure you're okay with why I'm introducing that exponent of 3. It is the hardest thing we're going to do. Gives me x minus 3 down here. 2 cubed is not 6. If you wrote 6 on your paper, erase it now, please. 2 cubed is 2 times 2 times 2, which is 8. Mr. Wood, all I got to do to solve this equation is add 3 to both sides. So x is going to equal 8 plus 3, which is 11. That's it. We're done. You can always check your work here real quick. 2 times the cube root of 11 minus 3 equal to 4. This is your check. This is kind of setting you up for checking later. 2 times the cube root of 8 equal to 4. The cube root of 8 is 2. 2 times 2 is 4. That's a check. Mr. Wood, you said it was going to be easy. I didn't know it was going to be this easy. I told you, if you were good with what we're going to do yesterday, you're going to be good with what we're doing today. Next problem. Sorry, I had to pause the video there. Next problem. Cube root of x minus 5 plus 1 is equal to 1. I'll give you guys a second to copy that down. You're going to see that this one actually follows the same format as the previous one. Again, that's a cube root of x minus 5 plus 1 equal to negative 1. Again, we're going to get the radical by itself, introduce an exponent to both sides of the equation, and then solve. Isolate. First step we're going to do here is minus 1 from both sides. And that's going to give us the cube root of x minus 5 equal to negative 2. To get rid of a cube root, I will introduce an exponent of 3 to both sides of the equation. The cube root of x minus 5 cubed will simplify. Hopefully you guys are seeing this patterning to x minus 5. The right-hand side is negative 2 cubed. Be careful here. That answer is going to be negative 8. Negative 2 times negative 2 times negative 2 is negative 8. Finish up this problem. Add 5 to both sides, and x equals negative 3. You can substitute in, check your work again. That says the cube root of negative 3 minus 5 plus 1 equals to negative 1. That's what we're checking. That's the cube root of negative 8 plus 1 equal to negative 1. But Mr. Wood, we can't take the cube root of a negative number. No, we can't take the square root of a negative number. We can take the cube roots or odd numbered roots of negatives. The cube root of negative 8 is negative 2. Negative 2 plus 1 is negative 1. That answer checks out. X equals negative 3 is our solution. That's what we're looking for. I see how this is going. Now give me something hard. Why don't you guys do that checkpoint? You need to pause the video. This is your first checkpoint on your green piece of paper. Go ahead and do this problem. When you're done, unpause the video. I will want this problem at the start of class tomorrow. All right, hopefully you get that checkpoint done. We're going to go ahead and move on to the next problem. Next problem. The quantity of 3x plus 4 to the 3 halves is equal to 64. That looks scary, Mr. Wood. I'm afraid I can't handle it. It looks hard. It's not hard. The same game. Isolate the radical. There's no radical here. Yes, there is. Radicals are fractional exponents. Well, what do I do? It's already isolated, Mr. Wood. It says 3x plus 4 raised to the 3 half equals 64. Well, if I've already isolated it, the next part is raise it to an exponent. I don't know what exponent to raise it to. I don't know. How about the reciprocal? If I raise it to the 2/3 exponent, I will distribute the 2/3 to the 3 halves. 2/3 times 3 halves is 1. And oh me, oh my, I am shocked to see that when I multiply 2/3 by 3 halves, my exponent of 3x plus 4 becomes the power of 1, which is just 3x plus 4. It's almost as if that's supposed to happen. That kind of makes sense, Mr. Wood. Good, it's supposed to. If I introduce the 2/3 on the left-hand side of the equation, I need to introduce an exponent of 2/3 on the right-hand side of the equation. Common mistake, students multiply by 2/3 instead of raising to the exponent 2/3. This is 64 to the 2/3. It is not 64 times 2/3. So I have 64 raised to the 2/3. You guys actually know how to simplify that. 64 to the 2/3 means the cube root of 64 squared. The cube root of 64 is 4. 4 squared is 16. So the right-hand side of my equation simplifies to 16. The right-hand side says 3x plus 4. That's algebra 1. Solve for x. Minus 4 from both sides. 3x equals 16 minus 4, which is 12. Divide both sides by 3. And x equals 4. Easy peasy lemon squeezy. You can check your work. You can do it mentally in this problem if you want. Stick 4 in for x. 3 times 4 is 12. 12 plus 4 is 16. I will first need to square root 16, which is 4, and then I will cube the number 4, which is 64. You can check it by hand if you'd like. Mentally, I don't care. Make sure that your answer matches. Next problem. It looks harder. It's not. The big difference that I will look at as you're copying this down, I'm going to show you example number 3 again. Negative 2x raised to the 4/3 minus 21 equals negative 53. Again, copying this down, glance up at example number 3 and look for the big difference between the two. And I'll show you in just a sec. Again, this is negative 2x to the 4/3 minus 21 equals negative 53. The process that we go, still isolate the radical. We need to get x to the 4/3 by itself. On the previous problem, the 3x plus 4 was raised to the 3/2 exponent. On this problem, nothing is connected to that x. That x is by itself. There's no parentheses connecting anything to that 4/3 and that x. Which means on this problem, I'm going to move the 21 over, and then I'm going to move the 2 over. On the previous problem, I didn't move the 4 over first, and I didn't move the 3 over because they were connected. The 3x plus 4 were all attached and connected to that exponent. So that's why I got rid of the exponent first in that problem. In this problem, it will be the last thing I do. Nothing is connected to that exponent and the x. So, add 21 to both sides. Negative 2x to the 4/3 equals, let's see, negative 53 plus 21. We've got negative 32. Next up, since the x is connected to the 4/3 but the negative 2 isn't, I will get rid of the negative 2 from both sides of the equation. And that gives me x to the 4/3. I have negative 32 divided by negative 2, which is positive 16. At this point, I'm ready to get rid of the exponent of 4/3. I will introduce an exponent of 3/4 to both sides of this equation. On the left-hand side, we'll simplify to x. Again, when I distribute, I get 1. Notice that I'm raising it to the reciprocal. Raise it to the reciprocal. This now becomes the 4th root of 16 cubed. Again, changing it to radical form. The 4th root of 16. The 4th root of 16. Remember to factor tree this. 1, 2, 3, and 4. 1 goes outside. The 4th root of 16 is 2. Now I need to cube 2. 2 cubed is 8. You can check your work if you'd like. Substitute it in. You'll have to take the cube root of 8, which is 2. Then raise 2 to the 4th power. You're going to get 16. 16 times negative 2 is negative 32. Negative 32 minus 21 is negative 53. Your answer matches. There's a check, just like there always is in Algebra 1. Next problem. I think there's just a couple more. Actually, pause the video. Do this in your next checkpoint location, please. Again, pause the video. Do this to the checkpoint. Should be turning it in on a green sheet of paper at the start of class tomorrow. I want your checkpoints on a sheet of paper at the start of class when you get into class tomorrow. Okay, hopefully you paused the video, did that checkpoint. We're going to finish up right now. This is kind of as hard as it's going to get today. I think these last two examples are kind of tricky. They're not too hard. They have a couple more steps. Okay? First off, this problem looks different than the other problems we've done. I have x minus 2 equals the square root of x plus 10. Again, x minus 2 equals the square root of x plus 10. The technique, isolate, introduce an exponent to both sides of the equation, and solve is exactly the same. There's nothing new technique-wise here. And hopefully you'll agree with me that on this problem, I've isolated the radical already. The square root is by itself. So that means I need to get rid of the radical. That says the square root, so what I'm going to do is square both sides. Remember, if there's no number there, it's a 2. So I'm going to square the square root. The right-hand side, that's the easy part. I got this. That's x plus 10. The left-hand side, don't be the student that writes x squared plus 4 there. Don't be the student that writes x squared minus 4 there. Be the student who multiplies x minus 2 squared out correctly. X minus 2 times x minus 2 is x squared minus 4x plus 4. I didn't write it down right. There we go. X squared minus 4x plus 4 equals x plus 10. Well, Mr. Wood, how do we solve this problem? Oh, I don't know. It looks like we have a quadratic equation. We have ways to solve quadratic equations. Well, how do we solve quadratic equations? Well, I'm glad you asked. The way that we solve quadratic equations is first by trying to factor. If we can't factor, then we use the quadratic formula. Oh, you mean that thing that we spent so much time on in the first half of class? Yes. You mean that thing that you said was going to keep coming up and again and again? That if I didn't know it, I'm going to be in trouble for the second part of class? Uh-huh. But I was good at that. Hopefully. Then all I have to do is set one side equal to 0 and try to factor it or solve. Yep. Minus x from both sides of the equation. Minus 10 from both sides of the equation. That gives you x squared minus 5x minus 6 equal to 0. I recognize this. Try to factor it. Two numbers are multiplied to give me negative 6, add to give me negative 5. Negative 6, positive 1. That means I have x minus 6 times x plus 1 equal to 0. I'm looking for solutions here, so x equals 6 and x equals negative 1. This is where the idea of an extraneous solution comes into play. I have two solutions. They might both be right. They might both be wrong. Or one might be right and the other might be wrong. Here's the other thing that happens. You must check in the original problem. So we've got to check in the original problem. My solution 6, I'm going to try that one first. I would say 6 minus 2 equal to the square root of 6 plus 10. 6 minus 2 is 4, equal to 10 plus 6, which is the square root of 16. 4 equals 4. Square root of 16 is 4. That is a true statement. That means at least x equal to 6 is a solution. Next up, check x equal negative 1. This will now say negative 1 minus 2 equals the square root of negative 1 plus 9. That says negative 3 equals the square root of, oops, I did that math in my head, I apologize. Should be negative 1 plus 10. Negative 1 plus 10 is 9. The square root of negative 9 is 3. Square roots, by definition, are positive. Negative 3 does not equal positive 3. Those numbers are different numbers. So negative 1 is not a solution to this problem. X equals 6 is my solution. I only have one solution to this problem, and it is x equals 6. Remember to check both your answers. Good problem. A little bit of factoring, a little bit of zero product property, a little bit of radical work. I like that problem. That's a nice problem. All right. Your checkpoint, go ahead and pause the video. And after you're done working through that checkpoint, again, remember I'm expecting checkpoints at the start of class. There will not be class time to do checkpoints. Expecting checkpoints at the start of class. And when you finish that checkpoint, go ahead and unpause the video. We have one problem left to do. Okay, hopefully you finished that checkpoint. We're going to look at the last problem. Before I get into that last problem, today's password that I'm looking for. The password that I'm looking for on your notes to see that you watched the video is Harry Potter. Harry Potter is today's password. All right, last problem. Wind velocity in a hurricane. Mr. Wood, do we really have to do a word problem? I will tell you that this word problem is easier than the last checkpoint problem you did. But there's so many words. So, read them. Figure out what the question's asking. Wind velocity in a hurricane. The mean sustained wind velocity, in v in meters per second, is given by this equation, where P is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. They've given me an equation, Mr. Wood. They've given me, I see two things in that equation with letters. And they've given me one thing that I think I have to substitute in. They've given me something in meters per second. That's velocity. Velocity is in meters per second. So 54.5 is my velocity. The question is asking me to estimate the air pressure. Well, P is the air pressure. So 54.5 must equal 6.3 times the square root of 1013 minus P. All I have to do is solve that for P. So all I have to do is isolate the radical, raise an exponent on both sides, solve for P. Isn't this just like all the other problems we've done all day? Well, this word problem isn't very hard then. I know. First thing we're going to do, divide both sides by 6.3. I'm going to use my calc for that because I don't know how to do it in my head. So that's going to be 54.5 divided by 6.3. Gives us that number. I'm going to call it 8.651. 8.651 equals the square root of 1013 minus p. Oh, I sure would like to get rid of that radical. However, do I get rid of a square root? I don't know. Square both sides, maybe? What a great idea. On the right-hand side, that gives us 1013 minus p. On the left-hand side, I'm taking 8.651. I'm going to square it. So I'm going to take 8.651. I'm going to take that answer. I'm going to square it. That gives you that number, 74.836. 74.836. At this point, solve for p. Minus 1,013 from both sides of that equation. Minus 1,013 from both sides of that equation gives us this. Negative 938.164. Negative 938.164. Well, I have a negative and a negative. Divide both sides of that equation by negative 1. And p is going to be approximately, because this is a decimal we've rounded, 938.164. And that is, or that represents, the air pressure in the center of the hurricane. Our units in this case are what's called millibars. I don't know what a millibar is, but I guess it's a measure of air pressure. Okay? Again, name of the game. Isolate the radical, introduce an exponent to both sides of the equation, solve the equation, check your work for extraneous solutions if you need to. That's it. See you guys tomorrow. Hasta la vista.